Okay, so today we're going to be talking about scatter plots and something called the line of best fit. Reading here, a line of best fit can be drawn to data that shows a correlation. The stronger the correlation between the data, the easier it is to draw the line. A line can be drawn by eye, and it should have roughly the same number of data points on either side. So let's look at this example that they have down below. So, number 1, the table below shows the shoe size and mass of 10 men. Problem A, draw a scatter plot for this data and draw a line of best fit. So what they had to do is they took all of these points, all of this data, they made them into ordered pairs and they plotted the dots. They plotted the points right here. Now, to draw a line of best fit, you're going to be drawing a line on your graph that basically goes through the middle of all of your data points. It kind of has how it has that grouping that kind of goes up. You're going to kind of draw it right in the middle of the pattern, in the middle of all the dots. You want to have roughly the same number of dots on top of the line as you have same number of dots on the bottom of the line. So up here I have 1, 2, 3, 4. Down below I have 1, 2, 3, 4. That one looks like it's about right on the line. So you always want to split your data. It's kind of like you're taking all those dots, you're splitting them in half, a top section and a bottom section. Okay? All right, so now we can go back and we can continue on. Question B says, draw the line of best fit, well we did, and comment on the correlation. The correlation is positive because that line, the slope of that line is positive. So it has a positive correlation, or positive association. Well, let's look at problem C. Use the line of best fit to estimate. The first thing they want to estimate is they want to know what is the mass of a man whose shoe size is 10.5. Well, I'm going to go find shoe sizes on the x-axis. So 10.5 is going to be between 10 and 11, right? I use that trend line to estimate, or that line of best fit to estimate. So I'm going to just kind of follow this up. And if I were to plot a point on that trend line, what mass does that correlate to? Follow it over here to your mass. Between 85 and 90, they estimated it to be about 87 kilograms. So you could expect someone with a shoe size of 10 to weigh about 87 kilograms. Please sit up and stay focused. All right, let's look at the second one. If somebody has, they want to know what is the shoe size of a man who has a mass of 69. So instead of going on the x-axis, because the x-axis is shoe size, that's what I'm trying to figure out. I have to find the mass on the y-axis that is 69 kilograms. Well, here's 65 and here's 70. 69 is going to be really close to 70, right below it. So you follow it. If I were to put a dot on that trend line, what shoe size does it correlate with? 6. Shoe size of 6. So that was about 87. The shoe size was about 6. Okay? So that's why we kind of draw that line through all the dots and all the scatters. It just helps us when we're trying to make estimates or predictions. Okay? We want the predictions to follow that pattern, this pattern of going up. I wouldn't want to estimate somebody way up here because that doesn't fit the pattern. If it was way up here, that would be an outlier, right? Remember we talked about outliers yesterday. All right, so let's open it up. Let's do some practice. All right, question number 1. The following scatter plot shows Pam's training as she prepares to run a 6-mile race at the end of the month. Which of the following would be a reasonable approximation for the length of the time that it would take her to run 6 miles? So I'm trying to find out how long would it take her for 6 miles. Well, 6 miles is right here, but there's no dots around here. So what do we need to do? We're going to have to estimate. What tool, what strategy helps us estimate? What did we call that line? The line of best fit, or you could call it a trend line. So now I'm going to draw this up. I'm going to kind of estimate. It does not always have to start at the origin. I'm just trying to draw it so I can split my data in half. So I can split my data. Here I have about 3 dots on top. 1, 2, 3, 4, so on bottom. Is this going to be a perfect trend line? No. But it should be close enough that I can get an estimate and one that I will be able to pick out my correct answer choice. All right, so we're looking again for 6 miles. Well, let's follow this up. If I were to plot this on my graph, come all the way over. On my line fit, it looks like it's just below 60, right? Maybe 59 or so, just right below it. Well, look at my answer choices. What do you think would be the best answer choice? I have 50, 45, 80, and 60. It's closest to 60, right? Because 60 is right here. My line was just right below it. Because remember, again, we're estimating. Now watch, I'm going to plot the wrong answers, and you can see why they are the wrong answer. So at 50 minutes, if I took 6 miles and it only took 50 minutes, look how far that wrong answer is away from that trend line. So 50 cannot be the answer. Same thing with 45. If I went 6 miles, if it took me 45, whoa, that's even farther away from my trend line. That's further away from that pattern, isn't it? It wouldn't make any sense. And 80, 6 miles, if it took her 80 minutes, 60, 70, 80, that's going to be way up here. So you can see this point at 59 is the closest to my answer, 60. Sound pretty good? All right, let's look at the next one. Question number 2. This one's like the one on the warm-up, and everybody did phenomenal on the warm-up. Which sentence describes the relationship shown in the scatter plot? Well, let's look at the scatter plot. What's happening? Well, here, my temperatures, are they going up or down? My numbers are going up. So what's happening as I'm moving through the graph, as my temperatures are getting higher, what's happening to the number of visitors here? It's increasing as well. So as my temperature goes up, my visitors goes up. Notice, arrows going the same direction. What kind of association is that? That's positive. Does this graph show a positive association or correlation? Yes. So now we need to find out which one says that temperature goes up, visitors go up. Or could you even turn it around and say if the temperatures go down, your visitors are going to go down? It would be the same thing, right? Okay, let's look. Answer choice A, as the temperature decreases, the visitors increase. Is that true? Nope. What about this one down here below? As the visitors increase, the temperatures decrease. Nope. As the temperature increases, the number of visitors increase. Yes, that would be my true statement. And of course, the last one, no correlation. Well, that's obviously not true because I see a positive correlation. All right, what questions? Any questions? How do we feel? Give me a thumbs up, thumbs down, thumbs sideways on this. Oh, I even got an A-OK. All right. Okay, let's do last 2 examples. Scatter plot shows the test scores based on hours of sleep. Estimate the test scores after getting 3.5 hours of sleep. So if I have to estimate, what do I need to do to help me estimate? Draw that line, that trend line. Now, remember, I'm just going to try to plow right through the middle of all of this data. So I have dots on top and dots on bottom, about the same number. So, I don't know, maybe just kind of eyeball it. That kind of looks a little even. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Those two are really close. Pretty close. All right, so what's the magic number we're looking for hours of sleep? 3.5, 3.5. So that's going to be between 3 and 4. Let's go up to the trend line. Where does that match in test scores? 75. Do I have an answer choice that's close to 75?
Yeah, 75.
You betcha. We have one that's exactly 75. You betcha. All right, last one. See if you can do this one on your own. Take a few minutes, see if you can do this one on your own, and then we're going to check it. Okay, let's look at it. Mr. Larson recorded the heights and arm span of students in his science class. What's an arm span? Right, if you stretch your arms out, from fingertip to fingertip is your arm span. All right, which best predicts the arm span of a student who is 66 inches tall? Uh-oh, we're having to predict. What do I need to do to help me predict? Draw my line. So I'm going to try to split my data as best as I can. Not perfect, but it's pretty close. Those of you on Cami, I do know there's a straight line tool that you can use to help draw your line if you need. Or you can freehand it like we're doing. If you ever need a ruler in here, there's rulers up there. All right, so what's the magic number? We're looking for how tall? 66 inches. So 66 right here. Follow it up. In my line, it correlates kind of like right here. It's really close. It's definitely not 65, because 65 would be right in the middle, wouldn't it? So if you wanted to round it to a whole number, I would absolutely be okay with about 66 inches. If you wanted to be specific and say 65.9, fine. But you're never going to have an answer choice where you have to choose from 69.5 and 66. It'll be an obvious, easy choice. Are there any questions? Okay, glue this in your spiral.